The cable that controlled a 1930s scraper was half an inch thick. That is it. Half an inch of wire rope between the operator and a 12-ton bowl full of dirt moving at speed behind a Caterpillar diesel. When that cable snapped, and it did snap, the short run between tractor and scraper whipped back with enough force to kill the man in the seat. On LeTourneau's own two-wheeled Tournepull tractors, the cables ran directly over the operator's head. One model kept that routing for over 20 years before the manufacturer finally moved the cables in 1958. These were the machines that built America in the 1930s. Fort Peck Dam, Bonneville Dam, the TVA, LaGuardia Airport, the Pennsylvania Turnpike. Billions of cubic yards of earth moved by men sitting on open steel seats with no rollover protection, no hearing protection, and a half-inch cable between them and disaster. This is the story of the cable scrapers. The machines, the men who ran them, the companies that built them, and the projects that would have been impossible without them. We are going to cover it in 4 parts. First, how scrapers went from horse-drawn tools to cable-controlled machines. Second, who built them and how the technology actually worked. Third, the massive Depression-era projects where these machines proved themselves. And fourth, the human cost, the danger, and why the cable era finally ended. We spent weeks on this one, and some of what we found has never appeared in a YouTube documentary before. Let us start where every scraper story has to start. In a blacksmith shop in Fresno, California, in 1883. James Porteous was a Scottish immigrant who arrived in Fresno County in 1877 and opened a wagon shop called Fresno Agricultural Works. Over the next 13 years, Porteous did something that gets overlooked in most accounts of scraper history. He did not simply invent the Fresno scraper. He consolidated it. He filed 3 patents of his own between 1882 and 1883. U.S. Patent 261,759 for the original buck scraper with its 8-foot front board and steel cutting edge. Patent 275,075 for the adjustable dump control. And Patent 289,134 for the handle and tongue mechanism. Then he bought 2 more patents from other inventors in the region. Patent 275,893 from William Diedrich of Selma, California, acquired in 1889, and Patent 320,055 from Frank Ducey and Abijah McCall, also of Selma, acquired in 1896. The Ducey and McCall patent came with a story worth knowing. McCall was a blacksmith. Ducey loaned him $150 to file the patent in exchange for half interest. When McCall died in 1886, his son sold the McCall half to Porteous for just $1,000. Ducey later sold his own half for $5,000. So the tool that would move more earth than any hand implement in history was assembled through a series of quiet financial transactions in California's Central Valley. The Fresno scraper was a significant advancement, but it was not the first scraper ever built. Scrapers in various forms go back to the Flemish Muldebeer of 1824, through the slip scrapers used on the Erie Canal in 1825, to Benjamin Slusser's all-steel slip scraper patented in 1876. The city of Sydney, Ohio, was once called the steel scraper capital of the world because 3 separate companies there built competing models. The Fresno was one important stage in a long development, and Porteous deserves credit for perfecting it, not for inventing the concept itself. Standard Fresno sizes were 3.5 feet, 4 feet, and 5 feet wide. The 5-foot model pulled by a 4-horse team was the most popular, priced at $37. A good team could move up to 225 cubic yards of dirt per day on a long shift, at a cost of roughly 6 cents per cubic yard on short hauls. That sounds efficient until you compare it to what came next. Fresno's were licensed to Galleon Iron Works in Ohio and J.D. Adams in Indianapolis. They were exported to South America, India, Australia, South Africa, and Europe. They went to the Panama Canal. They went to the Los Angeles Aqueduct between 1908 and 1913, where 52 mule teams dragged them through the Owens Valley alongside the very first Holt Caterpillar tractors. And they launched empires. In 1905, a Danish immigrant named Morrison-Knudsen showed up at a canal project in Boise, Idaho, with one team of horses and one Fresno scraper. He could move maybe 200 cubic yards a day. He met a superintendent named Harry Morrison on that job. 7 years later, they co-founded Morrison-Knudsen. That company eventually reached a valuation of $1.86 billion. A billion-dollar construction empire that started with one man, one horse team, and a $37 tool. If you are enjoying this so far, hit like and subscribe. We cover construction history and heavy equipment every week on this channel. The transition from horse-drawn Fresnos to tractor-pulled cable scrapers happened in stages, and the key moment was not an invention. It was a labor dispute. In 1920, a broke earth-moving contractor in Stockton, California, named R.G. LeTourneau, bought a worn-out 1915 Holt 75 crawler tractor for $600 down and rented a Schmeiser scraper from a man named Ira Guy for $1.50 a day. Running that rig required 2 men, one on the tractor, one on the scraper. The problem was, the California ranchers LeTourneau worked for refused to provide a scraper operator for more than 10 hours a day. LeTourneau needed 14-hour days, dawn to dusk, to make the economics work. So within 2 weeks, he rigged the Schmeiser so one man could control both machines from the tractor seat. The entire cable control industry, every power control unit ever built, traces back to that dispute over working hours. We have already covered LeTourneau's full biography and his cable control system in detail on this channel, so we will not repeat that here. In this segment, we want to look wider. LeTourneau was not the only company building scraper equipment in the 1930s. He was the biggest, and he held the most patents, but at least a dozen manufacturers competed for the same market, and some of them solved problems LeTourneau never touched. Take LaPlant-Choate Manufacturing of Cedar Rapids, Iowa. The company was founded in 1911 by Edward LaPlant and his nephew Roy Choate, originally as a stump puller company. They entered the crawler attachment market in 1923 when a Cedar Rapids newspaper called their product the first bulldozer blade manufactured on a commercial basis. That blade was mounted on crawler tractors using a hand-operated screw mechanism, raised and lowered by muscle power or by a second man. Then around 1925, LaPlant-Choate developed a gear-type hydraulic pump and began building hydraulically controlled bulldozer blades. That detail is often written wrong. Hydraulic control on construction equipment did not begin in the 1940s or 50s. LaPlant-Choate had it in the mid-1920s. Their 1930s scraper line was branded the Caramore, a deliberate jab at LeTourneau's carry-all name. Models ranged from the C-74 for Caterpillar D7 tractors up to the massive C-104 with a 33 cubic yard capacity. One thing that made LaPlant-Choate unique was that they never built a power control unit. Every cable scraper they sold required a power control unit sourced from LeTourneau, GarWood, or Isaacson Iron Works. That gave LeTourneau effective monopoly control over the cable architecture of the entire 1930s scraper industry. If you bought a LaPlant-Choate scraper, you were still buying a LeTourneau power control unit to run it. Western Wheeled Scraper Company of Aurora, Illinois was another major player. The company was founded in 1877, and its entire first-year production of 600 scrapers went to a single customer. Captain C.H. Smith of Mount Pleasant, Iowa, used all 600 on a 40-mile railroad grading job for the Chicago, Burlington, and Quincy Railroad. By the 1930s, Western Wheeled had merged with F.C. Austin Manufacturing to form Austin Western, and in 1935 they introduced the 12-yard, the first all-hydraulic four-wheel towed scraper ever built. It carried its own onboard gasoline engine and hydraulic pump on the rear of the bowl, because no tractor of the era had adequate hydraulic flow. It was photographed under test at Moffett Coal Company in Sparta, Illinois, on June 25, 1936. Sales were poor. Contractors did not trust 1930s hydraulic seals in dusty conditions, and they were right not to. Bucyrus-Erie entered the scraper business in 1935 by hiring 2 engineers away from Wooldridge Manufacturing. Those 2 men designed the entire Bucyrus-Erie throw-arm cable scraper line, including the S45, S67, S90, and S152 models. The whole Earthmoving division was eventually sold to International Harvester in 1953. Other manufacturers worth knowing include Wooldridge of Sunnyvale, California, founded in 1927, which ran an operator training school as early as 1931. Heil Company of Milwaukee entered scrapers in 1932, and Heil dump bodies were among the most numerous machines at Hoover Dam. GarWood Industries of Detroit built the 1938 Load Packer, the world's first compactor garbage truck, and also produced a full line of cable scrapers. Isaacson Iron Works of Seattle supplied power control units and scraper bowls primarily for International Harvester crawlers. Here is a fact that surprises almost everyone who hears it. During the entire 1930s, Caterpillar did not build its own scrapers. Not one. Caterpillar shipped tractors, and companies like LeTourneau, LaPlant-Choate, and Wooldridge built the attachments that made those tractors useful. The partnership between Caterpillar and LeTourneau was so close that LeTourneau built his Peoria factory in 1935, right next door to Caterpillar's East Peoria plant, so freshly assembled tractors could roll directly into his shop. LeTourneau supplied over 70% of all bulldozer blades, scrapers, and cable controls shipped on Caterpillar tractors through 1944. Caterpillar's first own brand scraper, the number 70, did not appear until 1946. Now let us talk about how these machines actually worked, because the cable control system is one of the most misunderstood technologies in equipment history. The standard hoist cable on a 1930s LeTourneau scraper was half-inch diameter, 6x19 construction, improved plow steel, internally lubricated, right lay. Every operator we have spoken to assumed scraper cables were 3/4 inch or larger. They were not. Half. The cable routed from the scraper bowl through a lower swivel sheave, up through an upper swivel sheave mounted on tapered roller bearings, and onto the drum of the power control unit. The power control unit itself was an enclosed winch driven from the tractor's internal power takeoff shaft. Every crawler tractor of the era had an internal splined shaft designed to accept either a power takeoff attachment or a power control unit. The drive ran through stub spur and herringbone gears exclusively. LeTourneau eliminated all bevel and worm gears from the power control unit because they generated too much heat and created lubrication problems. The entire gear case was sealed and ran in oil, which meant dust and grit were not an issue inside the unit, despite what some accounts claim. The operator controlled the scraper with levers that came from behind, over the top of the fuel tank. Pull the lever toward you to spool cable in and lift the bowl. Center position engaged the brake automatically through a torsion spring. Push the lever away to release the brake, and the weight of the bowl unspooled cable by gravity. This is important. Cable scrapers had no positive down pressure. The bowl cut into the earth only under its own weight. That was the fundamental limitation that hydraulics eventually solved. On Caterpillar cable scrapers, the apron lift cable also actuated the ejector function through a set of sheaves within the draft frame. As the apron reached its upper limit, all remaining force transferred to the ejector. The apron cable did not require its own separate drum. This was elegant engineering that kept the power control unit simple while extracting two functions from one cable. The double-drum Model T was the workhorse of the 1930s. Drum 1 handled the bowl hoist, Drum 2 handled the apron line. A 4-drum version existed for the D8, but smaller tractors could not handle the torque. The sheaves were 9 3/8 inches in diameter, large enough to prevent fatigue cracking from sharp bends. Cable life ran roughly 50,000 to 150,000 cubic yards of work, depending on conditions. Inspection was required every 100 hours, and replacement was mandatory when broken wires exceeded 6 in any one lay length. The cutting edges on the scraper bowl were bolt-on high-carbon steel, attached with flat-headed plow bolts that seated flush against the dirt face. LeTourneau's LP scraper introduced the 3-section cutting edge, a center section, and 2 end bits, so the most worn middle section could be replaced alone without pulling the entire edge. That became the industry standard. A full replacement set cost under $100. If you are learning something new from this, hit like and subscribe. We have covered the technical details of the LeTourneau cable control system in a dedicated video on this channel, and we have a full documentary on the 1950s Caterpillar versus LeTourneau scraper war as well. Now, where did these machines actually work? The answer is everywhere. But the biggest proving ground for cable scrapers was the wave of federal construction projects that swept across America during the Great Depression. Fort Peck Dam in Montana, started in 1933, required over 126 million cubic yards of earth fill. Caterpillar corporate records state that there were 21 Caterpillar machines on site for every one competing tractor. The workforce peaked at 10,546 in July of 1936, with an additional 40,000 people living in surrounding boomtowns with names like Wheeler and Macomb City. A Caterpillar operator at Fort Peck earned roughly 75 cents an hour. That was 8 times what a hired farmhand made in a year, and 2.5 times a steelworker's annual wage. Men rode boxcars across the country just for a chance at those jobs. Fort Peck also produced one of the most haunting construction disasters of the era. On September 22, 1938, at 1:15 in the afternoon, 1,700 feet of the upstream slope failed when bentonite seams in the Bear Paw Shale gave way. 5.2 million cubic yards of earth moved in seconds. 180 men were in the slide area. 34 were injured. 8 were killed. 6 of the 8 were never recovered and remain entombed in the dam to this day. Albert Stosser, age 23. Nelson Van Stone, age 31. Douglas Moore, age 35. Archie Moyer, age 26. J.I. Johnson, age 25. Oliver Bucher. Dolphy Paulson, age 41. Walter Lubinge, age 20. Total construction deaths at Fort Peck over 6 years reached 60. Margaret Burke White's photograph of the Fort Peck spillway appeared on the cover of the very first issue of Life magazine on November 23, 1936, putting cable scraper era Earthmoving on the cover of America's most prestigious photo publication. TVA built an entire cascade of dams through the 1930s. Wheeler Dam on the Tennessee River was 6,342 feet long. Pickwick Landing had a 63-foot single lift lock. Hiwassee Dam in North Carolina was 307 feet tall, the highest overspill dam in the world when completed. Cherokee Dam was built in just 16 months as a wartime emergency, completed December 5, 1941. 2 days before Pearl Harbor. Bonneville Dam on the Columbia River cost $83 million and employed 3,000 workers at peak. The spillway contractor was Columbia Construction Company, a joint venture of 5 of the 7 firms that had just finished Hoover Dam. Ordinary labor paid 50 cents an hour. For each competing tractor on site, contractors used 19 Caterpillar machines. Parker Dam on the Colorado River was the deepest dam in the world. It was 320 feet total height, with 235 feet below the original riverbed. 73% of the structure was underground. Frank Crowe, the same man who had just supervised Hoover Dam, was general superintendent. When Arizona's governor sent National Guard troops to halt construction in 1934, it took the United States Supreme Court to settle the dispute. A dormitory fire on February 3, 1936, killed 10 men. 7 died in the flames, and 3 more died from burns in hospital. Shasta Dam in Northern California went to a 12-company joint venture called Pacific Constructors for $35 million in 1938. Frank Crowe, again. 6.5 million cubic yards of concrete. The world's longest conveyor belt at the time was 9.6 miles long, built by Goodyear Tire Company. Henry J. Kaiser had bid on Shasta and lost. He called it the best contract he ever lost because it pushed him to build Permanente, the world's largest cement plant near San Jose, and to supply 6 million barrels of cement via the Goodyear Belt. Kaiser took gravel delivery cost from Southern Pacific Railroad's 27 cents per ton down to 18 cents. That loss propelled Kaiser into cement, then steel, then Liberty ships, then Kaiser Permanente hospitals. Morrison-Knudsen, the company that started with 1 Fresno scraper in 1905, took its cable scraper expertise overseas. In 1939, Morrison-Knudsen led the contractor's Pacific Naval Air Bases Consortium. They built airfields at Wake Island, Midway, and Kaneohe Bay in Hawaii. On December 7th and 8th, 1941, 1,221 Morrison-Knudsen civilian contractors were captured by Japanese forces at Wake Island. It was the largest single mass capture of American civilians in the Pacific War. And then there was Hansen Dam in Los Angeles, authorized after the March 1938 flood that killed 115 people. This is a project that rarely appears in equipment histories, but it should, because Hansen Dam was the first major earth-moving job ever done primarily by motor scrapers. Guy F. Atkinson Company ordered 10 LeTourneau Model A 1 tornapulls with 30 cubic yard double bucket carryalls in late 1938. At a time when the standard pull scraper held 8 to 12 cubic yards, this fleet was over a decade ahead of the industry. Those machines were still cable-controlled, but they signaled the beginning of the end for the towed cable scraper era. Beyond the dams, cable scrapers built the Pennsylvania Turnpike, America's first superhighway, funded with $40.8 million in Reconstruction Finance Corporation bonds and $29 million in Public Works Administration grants. 15,000 laborers broke ground in October 1938 and opened the road in October 1940 with no posted speed limit. The Clear Ridge Cut, 153 feet deep and half a mile long, was at the time the deepest highway cut ever attempted in the United States. Workers called it Little Panama. Cable scrapers built LaGuardia Airport, where almost 12,000 Works Progress Administration workers moved over 17 million cubic yards of fill starting in 1937. They built the All-American Canal, 80 miles long with a capacity of over 15,000 cubic feet per second, the largest irrigation canal in the United States. The Civilian Conservation Corps operated 45,000 pieces of heavy machinery, mostly Caterpillar, across 3 million enrollees over 9 years, building roads, dams, and state parks from coast to coast. One story from this era that almost nobody knows. Fort Dam in California started in November 1939, contracted to the Bent Brothers and Griffith Company for $8.7 million. 1,500 workers at peak. 5 workers were killed in 1940 alone. While gathering river gravel for the dam, workers struck gold. Under a supplemental contract, the contractors recovered 5,428 ounces of gold and split the profits with the federal government after deducting $24,000 for the recovery plant. They went looking for gravel and found a small fortune, and one man connects 3 of these mega projects. Frank T. Crow served as construction superintendent on Hoover Dam, then Parker Dam, then Shasta Dam. 3 of the most consequential dams in American history. The same man at the helm of all 3. Crow is the human spine of the entire 1930s federal earth-moving era. If you have a family connection to any of these projects, we would genuinely like to hear about it. Hit like and subscribe and drop your story in the comments below. The economics of these projects are worth understanding because they explain why cable scrapers spread so fast during the Depression. A new Caterpillar tractor in the late 1920s cost $5,000 to $6,000. A LeTourneau carryall scraper cost $2,500 to $4,000. A complete rig ran $7,500 to $10,000, which in today's money is roughly $170,000 to $230,000. A typical federal earth-moving job ran 5 to 20 tractor scraper pairs. The New Deal, the Public Works Administration, and the Works Progress Administration created demand at a scale the industry had never seen. Fort Peck alone cost over $100 million. The entire interstate highway system, authorized in 1956, would eventually move 42 billion cubic yards of earth, more than 400 times the volume of the Panama Canal. Cable scrapers moved the first generation of that dirt. Now let us talk about what it was actually like to sit in that steel seat. A cat skinner in the 1930s earned 75 cents an hour on federal dam work. That was $6 for an 8-hour day, roughly $1,800 a year. Shovel operators earned the most at $1.25 an hour. Laborers earned the least at 50 cents. The Davis-Bacon Act of 1931, signed by President Hoover, required prevailing local wages on federal contracts over $5,000, and it had a complicated racial history that shaped who got hired on these projects and at what rate. Open cabs were universal. The Caterpillar diesel 6018.5-liter gasoline 4-cylinder ran at 650 revolutions per minute, with mechanical valve gear and an exposed exhaust. Modern equivalents register over 100 decibels at the operator's ear. Permanent hearing damage was effectively universal, but completely undocumented. Every morning started with a small 2-cylinder gasoline pony engine to warm the big diesel. That put-put-put, followed by the deep whoom of the main engine firing, was the sonic signature of dam camps at dawn. Before LeTourneau's cable control system, scraper rigs needed 2 men. After cable control, one operator ran both machines from the tractor seat. That was a major Depression-era labor displacement. One skilled cat skinner replaced 2 workers overnight. The term cat skinner itself came from the mule era, when the same men had skinned mule teams. They carried the name forward to diesel tractors. At Hoover Dam, 6 companies built bunkhouses for 480 single men at River Camp. Married workers initially lived in a squatter settlement called Ragtown before Boulder City was built. For $1.60 per day, workers received a private room, a bed, bedding, meals, and transportation to and from the construction site. The real scandal at Hoover was the carbon monoxide poisoning. 42 tunnel workers died after gasoline trucks were driven into unventilated diversion tunnels. 6 companies' medical staff diagnosed every single death as pneumonia, Not one non-worker in Boulder City died of pneumonia during the entire construction period. The 1936 congressional hearings exposed the fraud. The danger was constant, and the death toll was staggering. The Hawk's Nest Tunnel disaster in West Virginia from 1930 to 1931 killed between 109 and 764 workers, most of them black migrant laborers, from acute silicosis caused by dry drilling through nearly pure silica rock. Union Carbide's contractor refused to use wet drilling, except when state inspectors visited. Workers emerged covered in white dust. The company diagnosed every death as pneumonia. Black victims were buried in unmarked graves at a farm in Mount Lookout, West Virginia, because they were excluded from white cemeteries. A family member named Sheila Flack Jones later said about her uncle Dewey Flack that her father had told her he thought his brother had simply run away, and the family never knew the truth. At Polson Dam in Montana, on March 3, 1937, a cliff face collapse killed 8 men. 7 of them were tribal members of the Confederated Salish and Kootenai. Their names were Dave Sanchez, Clifford Gendron, Jack Anderson, Tony Adams, Henry Couture, Joe St. Germain, and Alan Ross. A rescuer named Harold McNeely died days later. Wages on that project ranged from 40 cents to $2 an hour. Edward Bullard patented the hard-boiled hat in 1919, inspired by his World War I Brodie steel helmet. The original cost was under $3. Hoover Dam in 1931 became the first major construction project to require hard hats. Joseph Strauss made the Golden Gate Bridge America's first official hard hat area in 1933. Before that, nothing. Before OSHA in 1970, enforcement of safety standards on construction sites was essentially voluntary. So why did the cable era end? Not because of a single invention. Cable scraper bowl capacities had tripled during the 1930s, from roughly 5 cubic yards on LeTourneau's early Carryall A up to 30 cubic yards on the massive HU double bucket models used at Hansen Dam. The machines kept getting bigger. They could have gotten bigger still. The problem was control precision. Cable could lift. Cable could release. But cable could not push down. And it could not hold a precise intermediate position under load without the operator fighting the lever constantly. A hydraulic cylinder can extend, retract, and hold any position in between under full load without any operator input at all. That single mechanical advantage made hydraulics inevitable for anything requiring precise grade control, which was almost everything. The transition was resisted by operators who preferred cable and delayed by World War II, which froze scraper development while advancing hydraulics in aircraft. Heil's hydraulic scraper line was discontinued during the war due to material rationing. LeTourneau alone supplied over 10,000 pull-type and over 2,000 self-propelled scrapers during the war, and the United States Army shipped over 1,700 Caterpillar tractors per month at peak production. Major General Eugene Raybould of the Army Corps of Engineers said in 1944 that victory seems to favor the side with the greater ability to move dirt. Post-war military surplus flooded the market with cheap cable-controlled D7 and D8 machines and LeTourneau carryalls, extending the cable era by years because contractors bought surplus instead of investing in new hydraulic equipment. The real end came in a single 14-month window. In September 1952, LaPlant-Choate was sold to Alice Chalmers. In May 1953, LeTourneau sold his earthmoving division to Westinghouse Airbrake for $31 million. In 1953, Bucyrus-Erie's earthmoving division went to International Harvester. Austin Western went to Baldwin Lima Hamilton, and Heil's scraper line went to International Harvester as well. 5 major acquisitions in 14 months, driven by the shared recognition that the cable era was ending, that hydraulics required heavy research investment, and that smaller manufacturers could not fund the transition alone. This was the consolidation that set up the modern equipment industry as we know it. And here is the part that catches everyone off guard. Caterpillar, the company most associated with hydraulics today, was a late adopter. Their number 40 scraper of 1949 was their first hydraulic model, a small 3.5 cubic yard unit for the D4. Every other Caterpillar pull-type scraper through the early 1970s remained cable-controlled. The Caterpillar number 435 was the last cable-operated towed scraper Caterpillar ever built. It was still in production in 1973. We found a forum thread where veteran operators debated cable versus hydraulic, and one of them wrote that the cable machine was essentially bulletproof. No hoses to get hung when clearing, no pumps to wear out or cross-contaminate the system. Another wrote that it was an unspoken rule that care of the cable was the operator's responsibility. If he broke it, he fixed it. He also greased the sheaves and fed new string through as needed. A third operator said the men who ran cable gear had an understanding of feel and sound that went far beyond anything on modern job sites. That is the real story of the 1930s cable scraper. Not just a machine. An entire industrial ecosystem rose from one man's frustration with a 10-hour workday, scaled to build the largest earth-moving projects in human history, employed hundreds of thousands of men during the worst economic crisis America has ever faced, and killed thousands in the process. It then consolidated into the modern equipment industry in a single 14-month window. The machines are gone. The last cable scraper rolled off a production line over 50 years ago. But the dams still hold. The highways still carry traffic. And the names of the men who built them, the ones we managed to find, deserve to be in the record. If you want to keep going deeper into this history, our full LeTourneau biography covers his 299 patents and his rejection by Caterpillar. Our Hoover Dam documentary covers the steel cables that killed 13 men in Black Canyon. And our 1950s Scrapers video covers the war between Caterpillar and LeTourneau that reshaped the entire industry. All of them are linked in the description below. Like and subscribe if you want more from Construction Legends. We will see you in the next one.